All right, everybody. So welcome. This is Bill Peppard, and I'm going to go through my um, final project with you guys. So I'm starting on the page, which is the course design matrix. So I did my lesson on module 1 of my conceptual physics class, which is describing linear motion. So all the MPOs are listed, which will be expressed in the HTML. We don't do all of them in this one lesson on the HTML, but this is all my MPOs here. For the materials or rubrics and assignments, there's a homework assignment, there's Edpuzzle videos throughout the unit. There's various online simulations, a couple of those we'll get into in the lesson here. There's another online activity that isn't really a lab, but it's more just assessing if they have learned the materials. There's an authentic assessment, which I need to change that. Okay. Which was my commute to campus activity where they had to figure out description using their GPS to describe the basic physics ideas in the unit that go along with that. There's a rubric there for that. And then obviously there's the assessment or the test at the end of the unit, which also has a rubric that's associated with the motion problems that they would do. Under the learner engagement activities, that's what those are really. So those assessments are those learning engagement activities, formative or summative. And then for learning materials, we use the textbook, which is a UIT conceptual physics book. I have my own materials that I've made up over the years, so those practice sheets that go along with those Edpuzzle lessons are there. There's online mastering physics homework, which goes along with the textbook, and then those online simulation labs through Physics Aviary, and there's another one through the Physics Classroom. So that's the last one there. So let me take you to the HTML page. So this is where I'm in my sandbox here, and I'm just going to click on the first page. This is my kind of introductory page and overview. So we're talking about the lesson that we're focused on is modeling motion mathematically. So at this point, we have learned the ideas and concepts of displacement, velocity, and acceleration, and we're going to keep working with graphing those concepts, and we'll be using them throughout this course. So and the initial thing that I have for them is like a 2 or 3 minute video on a channel called Flipping Physics.
Velocity and acceleration as a function of time graphs for a sliding street hockey puck.
So they take you through this little demo of he slides a puck, and they talk through all the different types of graphs that they're going to need to be familiar with and learn about. So so that is kind of a good introductory kind of idea. And then we're also, as an assessment at the end, we're going to revisit the video later and have them kind of watch the video again and see how much they understand more now at the end comparatively to when they first started looking at it. So this next link at the bottom will take you to the first Edpuzzle here. So it takes you to Edpuzzle 2.2. So again, this Edpuzzle is kind of the hybrid part of the class, or the online part of the class where they'd be learning a lesson from me. So I'm not going to show you that whole video because it's pretty lengthy, but I have gone through several different types of position, time, velocity versus time motion maps, and have to build their skills and practice their skills with using slope and area and all different, like understanding what the graph is showing. So there are a couple questions embedded in this video along the way that they have to progress through to be able to get to. The unit lesson is here, so they can click on any of these links and it will take them to various things. So position versus time graph, that would take them there. Let me go back. So it has all these links to the different materials that are discussed and talked about in the video, including answers to several of these up here. So the next thing they do is they click on, after they've kind of learned the lesson and reviewed all those different types of graphs, they're going to go to learning activities. So the learning activities, they are summative, so I've made that note for them. And I have an accordion page here set up where they have the 2 labs, so they would just click on here and this would take them to another page outside of D2L, which has all of the links there. So in all my some summative lab activities, I have a instruction video, I have the link to the actual site where they're going to be collecting data, the lab sheet that they're going to be filling in, and then where they submit it. So I close that out. And there's one for that activity that's a little more involved than this one, which is basically trying to simulate a lab using these ideas again, but same format. Again, instructions, the actual link, and then the submission. So after they've completed that, they've done pretty much all the learning for this part of the unit in that lesson activity, and we're going to wrap up and try to conclude. So in the concluding or wrapping up activities, it says complete the graph that motion activity. So this will take you to a separate page again, and students are going to go through and look at, and they could track their progress if they wanted to, but it gives them some sort of motion associated with the image up here. So this car is moving to the right, it stops, and then it starts accelerating away. So it repeats that, and you have to figure out which of these graphs. So in the beginning, it should be constant velocity, it looks like. So I think none of those are good so far. So this looks like it could be promising. So the position, if this is 0, it's increasing, it's going to the right, and then it stops for a while. That's not going to be right because it didn't move back to the left. So we'll keep going. It's not that one. No. This looks like it. So again, they're starting at some position, they increase that position to the right, then they stop for a while, and then they speed up going to the right. So again, they have to essentially be able to work with position time or velocity versus time graphs based on some sort of motion. We said it was that one. Hopefully I get it right. Yeah, so that's right. And they get a star. So there's 11 different processes they'll go through and trying to match up the right activity or the right kind of GIF image with the graph. So it's a really good summative kind of way to assess if they've learned those concepts. And then finally, again, like I mentioned, we're going to rewatch that initial YouTube video on flipping physics and kind of reflect on what they have learned. And if there's still something that they're confused about, then they can go back and revisit it. Okay, so there's my final project. Hopefully that's good, and have a good one.